Hi, a couple of weeks ago we talked about graphing quadratic equations in standard form, ax squared plus bx plus c. So I want to do one like that just to remind you of how that worked. Standard form, you have the terms going from highest to lowest power. A, these are a little crowded here, is the coefficient of the x squared term, so that's 1/3. B is the coefficient of the x term, so that's -2. And c is the constant term, so in this one that's -1. Whether a is positive or negative tells you which way the parabola is going to open. When a is positive, the parabola is going to open up. If a was negative, it would open down. To tell whether the parabola is wider or narrower than the parent function, you look at the absolute value of a. If the absolute value of a is greater than 1, that means the parabola has been stretched vertically, so it will appear narrower than the parent function. But when the absolute value of a is between 0 and 1, that means that it's been shrunk vertically by 1/3, so it will appear wider than the parent function. The axis of symmetry is a vertical line that divides the parabola into two reflected halves, and if it's in standard form, you can find the value of the x coordinate of where that crosses the x-axis by taking -b over 2a. So if b is -2, b is +2, and 2a would be 2/3. Well, remember, when you're dividing by a fraction, that's the same as multiplying by its reciprocal. So the 2's would cancel and you get 3. So x equals 3 would be the vertical axis of symmetry. So I'm going to go to 3 on the x-axis and I'm going to draw a dotted vertical line through there. And that is going to be the line that reflects the two halves of my parabola. And that's called the axis of symmetry. And its equation is x equals 3 in this case. Now the vertex, the axis of symmetry's x-coordinate is the x-coordinate of the vertex. And to find the y-coordinate of the vertex, you take the original equation and you substitute the x-coordinate of the vertex in for x. So 3 squared is 9. 2 times 3 is 6. 1/3 of 9 is 3 minus 6 would be -3 minus 1 is -4. So -4 is the y-coordinate of the vertex of this parabola. So I go to 3, -4, and that point is going to be my vertex. Now, once you've located your vertex, I'm not going to use the original equation anymore. I'm going to pick numbers. I'm calling it x prime because it's not really the x-coordinate. And I'm just going to pick 1, 2, 3 to get started. And then I'm just going to look at the ax squared part of my parabola, and I'm going to use these numbers for x. So 1 squared is 1 times 1/3 is 1/3. 2 squared is 4 times 1/3 is 4/3. 3 squared is 9 times 1/3 is 3. 4 squared is 16 times 1/3 is 16/3, which is 5 1/3. 5 squared is 25 times 1/3 is 25/3, and that gives you 8 1/3. And we'll see how far that takes us. Now, because I'm ignoring everything except the ax squared, instead of counting these coordinates from the origin, I'm going to count them from the vertex. So this tells me from the vertex, go right 1 and up 1/3. From the vertex, go right 2 and up 1 1/3. From the vertex, go right 3 and up 3. From the vertex, go to the right 4 and up 5 1/3. Oops, I went too far there. I went 5 instead of 4. From the vertex, go to the right 5 and up 8 1/3. So there was 5, 6, 7, 8 1/3. And I could probably even go one further. 6 squared is 36 times 1/3 is 12. So if I go to the right 6, this was 4, 5, 6, 7, 8, 9, 10, 11, 12. Now notice I only plugged in positive values for x, so all these points are to the right of my axis of symmetry. That's because each of these points can be reflected across that line the same distance away. So this point was 1 to the right, so on the same horizontal line I make another point 1 to the left of the axis of symmetry. 2 to the right, 2 to the left. 3 to the right, 3 to the left. 4 to the right, 4 to the left. 5 to the right, 5 to the left. 6 to the right, 4, 5, 6 to the left. And now I have plenty of points to connect with a smooth line from left to right to get that parabola. So that just reviews what we learned about a couple weeks ago. But now we're going to look at two different forms of the equation for a parabola. One form is called intercept form. Now, if you remember, we were talking about factoring. And when we factor, a quadratic equation ends up looking like this. Notice we've still got a in the formula, so a does the same thing it did before. If it's positive, the parabola opens up. If it's negative, it opens down. If its absolute value is greater than 1, it stretches vertically, so it gets narrower. If it's between 0 and 1, it shrinks vertically, so it looks wider. Okay? But the P and the Q are going to be the X-intercepts of the graph of the parabola. Because if you put 0 here for y, when this equals 0, y would equal 0. When this equals 0, y would equal 0. And the only way y could be 0 here is if x was p, because p minus p would be 0, or if x was q, because q minus q is 0. So the p and the q are going to be the x-intercepts of the graph. Now, since a parabola is symmetric, the axis of symmetry is exactly halfway between those two x-intercepts. And the way you find the number halfway between two is you add them together and divide by 2. You average them. So the x-coordinate of the axis of the symmetry in this form is going to be the average of p plus q. And once you know the coordinate of the vertex, the x-coordinate, you plug it into the equation to find the y-coordinate. So to look at an example like that, here we have an equation in intercept form, a number times a parentheses with x and a number added or subtracted, and another one with x and a number added or subtracted. So a is 1/2. P, remember the formula said x minus p, so that means to make this b plus, this would have to be x minus -2. So -2 is one of the x-intercepts, and x minus q means 4 is the other x-intercept. Because a is positive, it opens up. Because the absolute value of a is between 0 and 1, the graph is going to appear wider than the parent graph because it shrunk vertically. So the x-intercepts would be -2, 0, and 4, 0. Because remember, any point on the x-axis has 0 for its y-coordinate. Now, unlike the quadratic equation in standard form, to find the axis of symmetry, you take p plus q and divide by 2. So that's -2 plus 4 divided by 2. 2 divided by 2 is 1. So that means the x-coordinate of the vertex is 1. And then to find the y-coordinate, I take the equation I was given, 1/2 times 1 plus 2 times 1 minus 4. We just plug the number 1 in where the x was. So we get 1/2 times 3 times -3 would be -9/2, or -4 1/2. So that's going to be the y-coordinate of the vertex. So 1, -1, 2, 3, 4 1/2 is my vertex. And my axis of symmetry goes through that vertically. So that's x equals 1. The vertex here is 1, -4 1/2. My two x-intercepts, -2, 0 and +4, 0, are just, and now I'm not counting from the vertex, I'm counting from here for this. 2 to the left and 4 to the right. Now with those two on the vertex, that's enough to draw a rough sketch of your parabola. Once you've got 3 points, including the vertex, and even if they don't line up, you can draw a rough sketch of your parabola. If you want to be more accurate, then you could do like I did, where we took numbers and we just, this time, we'd use a as 1/2 and we just do 1/2 x squared. So if I plug 1, 2, 3 in there, 1 squared is 1, times 1/2 is 1/2. 2 squared is 4, times 1/2 is 2. 3 squared is 9, times 1/2 is 4 1/2. And if we count from the vertex, right 1, up 1/2. And I can reflect that. Right 2, up 2. And I can reflect that. Right 3, up 4 1/2. That puts me at these two intercepts. So because I did a rough sketch, I wasn't perfect, but I was close. This would actually be right there and there. So once you know the two intercepts, you just average those to find the x-coordinate of the vertex, plug it in to find the y-coordinate, and that gives you 3 points that's enough to sketch the graph. So let's look at another one like that. In this case, a is -3. P is, remember, it's x minus -2, so that'd be -2. And Q, x minus -5 would be -5. So A is negative, so this one is going to open down. The absolute value of A would be greater than 1. So this is going to stretch vertically, so it's going to look narrower than the parent function. And the x-intercepts are going to be at -2, 0 and -5, 0. So I'm just going to start with what I've got so far. I've got -2, 0, and I've got -5, 0. So those are my x-intercepts. Now to find the axis of symmetry, it's got to be halfway between those. So P plus Q over 2, x equals that number, is our axis of symmetry. So that's -2 plus -5 divided by 2 is -7 halves, which is -3 1/2. So 1, 2, 3 1/2, notice that is right halfway between the two x-intercepts. So I draw my vertical axis of symmetry there. Now I need to find the vertex. Well, the axis of symmetry is the same x-coordinate, -3 1/2. And then we need to plug it into the original equation. So we have y equals -3 times -3 1/2 plus 2 times -3 1/2 plus 5. So that's -3 times -1 1/2, and I'm going to change these into improper fractions because I have to do that in order to multiply. And then -3 1/2 plus 5 is +1 1/2. So I get 3 times 3 times 3. The two negatives make it positive 27, and 2 times 2 is 4. So 4 goes into 27 6 times with 3 left over. So that's positive 6 3/4 for the y-coordinate of the vertex. So negative 3.5, positive 1, 2, 3, 4, 5, 6 3/4 is the y-coordinate of the vertex. So now, this parabola is going to open upside down. Those 3 points are enough to sketch it. Remember, you don't want it to be pointy at the vertex, but it's got to go down pretty quickly through those 2 points because they're pretty close together on the x-axis. So that's graphing in intercept form, or using the x-intercepts. Okay, the other form is my favorite form, vertex form. A quadratic equation, oops, I'm at the wrong half of the page here, is in vertex form when it's a times a quantity x minus h squared plus k. And when it looks like this, a is exactly the same as it is in the other ones. If it's negative, it opens down. If it's positive, it opens up. If its absolute value is less than, well, between 0 and 1, it's going to shrink vertically so it looks wider. And if its absolute value is greater than 1, then it's going to stretch vertically so it looks narrower. But this time, the h and the k are the coordinates of the vertex of the parabola. And if you remember, when we graphed in the other two forms, the one thing that we really had to find to really be able to graph it right is the vertex. In this form, the vertex is practically given to you just as soon as you identify what h and k are. Notice in the formula it's x minus h. So if you see a plus when you're looking at a problem, that means that h value is negative. But it's plus k, so k will have the same value it appears to in the equation. So looking at this equation, comparing it to this form, a is negative 1/4, h, x minus h would be positive 3, and k would be positive 2. Since a is negative, it opens down. Since the absolute value of a is between 0 and 1, it's going to shrink vertically, so it's going to look wider than the parent function. Its vertex is hk, 3, 2. And remember, the x-coordinate of the vertex was always the same as the axis of symmetry. So that was x equals 3. So right now, I can plot the point 3, 2 as the vertex. I can draw the axis of symmetry. And that's going to be x equals 3. And now I just need to find one other point for this thing. Well, here again, you can use that little trick I showed you. Once you know where the vertex is, you can ignore everything except ax squared. So that would be negative 1/4 x squared, as long as you count from the vertex instead of the origin. So if I just plug in a few points, I really only need one, but I'm going to plug in a few so my graph can be more accurate. 1 squared is 1, times negative 1/4 is negative 1/4. 2 squared is 4, times negative 1/4 is negative 1. 3 squared is 9, times negative 1/4 is negative 9/4, which is negative 2 1/4. 4 squared is 16, times negative 1/4 is negative 4. Now let's just say I take the 4, negative 4. So from the vertex, I go to the right 4 and down 4. And that's another point on my parabola. Well, remember, the symmetry says this point is 4 units to the right of the axis of symmetry, so there's another point reflected horizontally 4 units to the left. So right there is enough to draw a rough sketch of my parabola. But again, if you want it to be more accurate, write 1 down a quarter, write 2 down 1, write 3 down 2 1/4, and then I can reflect all of those points. So I did pretty well on this side. I was a little off on this side. And you could even go farther if you went to the right 5. 25 times negative 1/4 would be negative 6 1/4. So that would be, this was, let's see, 4, 5, 6 1/4. And if you did 36 divided by 4 would be negative 9. So 7, 8, 9. So you've got the vertex, you just need to plug in something to find one other point, reflect it, and you've got enough to sketch the parabola. So for this one, A is 2, H is negative 3, and K is negative 8. Since A is positive, it opens up. Since the absolute value of A is greater than 1, then it's going to be stretched vertically, so it's going to appear narrower than the parent function. The vertex is HK, negative 3, negative 8, and the axis of symmetry is always x equals whatever the x-coordinate of the vertex is. So now, I can pick any other number than negative 3 that I want and plug it into this equation. I can do what I did up here. I prefer to do counting from the vertex, but you don't have to do it that way. You can say, okay, I'm going to plug 0 into the original function. 0 plus 3 is 3, squared is 9, times 2 is 18, minus 8 is 10. So 0, 10 is a point on this graph. Negative 3, negative 8 is the vertex. The vertical line through the vertex is our axis of symmetry. That would be x equals negative 3. This point is 3 to the right of the axis of symmetry, so I can go 3 to the left of the axis of symmetry. And then that's enough to draw a rough sketch of my parabola. It's going to be quite narrow because it has to go through those 2 points up here, but it also has to go through this vertex way down onto the bottom. Now here again, if I want to be more accurate, I can ignore everything except the ax squared. So if I go 1, 2, 3, I know 3 is going to be going off the chart here. So 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. So remember, when I do it this way, I'm counting from the vertex. Write 1 up 2 and reflect it. Write 2 up 8. Those are my 2 X-intercepts. And reflect it. Write 3 up 18. Those were these 2 points. So that can help you be a bit more accurate when you're drawing your parabola.